Yeah.
I did last time. Yeah. Oh, yeah. Probably like half. I was the one on that today.
I know.
Oh, you get that?
Your sister.
Yeah, I can say it. I don't know when this is.
I feel like.
Since I'm still in 29,
He is good.
can I take it the same day? I can take it at night, not at night.
I'll do it tomorrow.
Yeah, I
I'm
can.
here all morning. We'll just pick
Oh, yeah.
one of my classes.
Yeah.
One, it's 8 and 1:30. And then 12.
Okay.
That'll work.
That's the 29th, huh?
Yeah.
All right. Work.
Everyone, remember that chain rule sheet I passed out? If you want the solutions, I made those, so. If you wanted to work some of those, just to practice. They start out, you'll notice like the first 10 or 12 or 15 or 3, you're like, oh, these are quick, easy. They go a little more weird down near the end, with radicals and stuff, so. If you want to work them from extra practice, and then if you had a question, like, can you work one of these? I'd be more than happy to do it in class, if there's one in the budget. You're welcome. Yeah, I'll start with 22. Well, number 22 from this was that the toughest one?
Yeah.
Yeah, that was the toughest. So we'll start with the toughest. You're welcome. These are just extra practice. I'll even make some up off the top of my head. I would chain rule, D rule, chain rule, D rule. It's always getting applied. Students always want to know, when do I use it? Do it so often. You're welcome. But a lot of these, you may look at that list of these problems that I worked. It came from these exercises here. They're like, oh, these aren't that bad, they're quick, because that's what it is. Those first, like, at least the first 13 problems or so are the things you see all the time in the Calc 2, Calc 3 course. That's why I put them there. Like, these are things over and over and over and over again, right? It's the ones after the, did you want to copy the actual extra bit? And then, as you get towards the end, you get some tougher ones. So, okay. Hey, still in chain rule. Let's look at this. This is still in 3.4. Chain rule. If m equals f of g of x, chain rule, what's m prime?
F prime g of x
Anything else?
times g prime x.
Times g prime. There it is. That's chain rule. That's chain rule. All right, so 22. Some function equals 3x over the square root of 2x plus 1. What override rule should we start with? I see a big quotient. Quotient rule, right everyone? You see this big fraction. Quotient rule?
We can do product rule too.
If you do product rule, you'd have to bring this up and put it to what power?
Minus half.
Outstanding. Does everyone agree? You go, wait, how do you do product rule? He's saying, if you took that maneuvered it up here and just wrote 2x plus 1 to the negative 1/2. And that is totally fine. I'll just roll out quotient rule. We'll see how it goes. Okay, here, I'll call you M, and then I was gonna say F and G, but that's already F, so I'll just use M and F. So F prime will be low times D high minus high D low all over
Lolo.
Lola. Well, N's gonna be easy. Square root of 2x plus 1. M prime. That's a piece of cake, everyone, you agree? 3?
Mhm.
It's a low D high, piece of cake, low D high. You wanna put the 3 in front? Yeah, use please. That looks weird. We'll just put that right there. So there's low D high. There's N. There's M prime. Minus high. Another piece of cake. Then you got M prime, and it's all over N squared. What's that squared? That's pretty easy. What's the square root of 2x plus 1
2x
squared?
plus 1.
So boy, this thing's looking pretty easy, except for one thing. This part. You know? N prime. And what rules use?
Chain.
Chain rule. Do you all agree?
Mhm.
And you may even go off to the side, you go, all right, hold up. N equals, you might do this off to the side, just to figure out this N prime. N squared of 2x plus 1. That means N is 2x plus 1 to the 1/2 power, right?
Mhm.
So far, so good? Because I mean, I bet you all agree, like, all that was a piece of cake, so just right here. So now I'm gonna slowly work this derivative, which I see involves chain rule, because inside the radical, you go, why do you need chain rule? Inside the radical is just not an x, it's got a 2x plus 1, that quantity's underneath that radical. So we'll put a half in front, and I'll decrease this by 1. Anything else? Chain.
Minus
What's the chain? What's the derivative?
times 2.
2x plus 1 times 2. So that's that little chain. We just don't want to ever forget this little chain here. Without this, right there, this is the F prime of G. Right there. Here comes G prime. You say, well, there's my G. What's the derivative of 2x plus 1? Just a 2. Is that okay with that? This alone is tough, because we just started. I want to make sure everyone's got that. I know, not too tough for you, but you gotta be careful with it. And then we'll put it in there. Now anything cancel?
Mm-hmm. 2.5.
See, you got a half and you got a what?
2.
2. So not bad. What is this thing? 1 over, that goes back to a denominator. Is that okay if I write it like that?
Mm-hmm.
Okay. Check it over. See, that was the top. Look at all that stuff in there. Piece of cake, oh, and prime. Chain rule. Now this thing's nasty because I gotta have to put this fraction where? Up in here, huh?
Mm-hmm.
Looks like I'll have a complex fraction. Don't let it bother you. But I will admit, Evan, when I rewrite this for you on the board, I think I'm gonna raise this up here a little bit so I can squeeze in a what? That fraction. So there's enough room, right? I'm just gonna push this up a little so you can see it. Or drop the bottom bar like this here. Just out like that. Just leave some room here. Here we go. I think there's enough room now. All right, 3x times, what was this? 1 over square root of 2x plus 1, which means you get 3x over there. And what was still down that bottom? Just a what? 2x plus 1 alone. So we're done except for one thing, simplify the complex fraction. We don't want to delete this. We're going to simplify the complex fraction. And it's not that bad, Owen. If I want to subtract this part from this part, I need common denominators, right?
Mm-hmm.
This denominator has a square root of 2x plus 1. this one has, what's this over?
1.
So if I wanna make these common, do you agree? I just have to multiply square root of 2x plus 1 over square root of 2x plus 1 here?
Mm-hmm.
Yeah? All right, I'm gonna do that. So I'm about to leave this alone, go over here and multiply square root of 2x plus 1 over square root of 2x plus 1. All right, and I'll do it with the yellow chalk. I get it easy because I have a chalkboard. I get to erase and add things. But you might do a whole nother step in your work so you can see this progression. So I'm going over here and I'm multiplying a square root of 2x plus 1 over a square root of 2x plus 1, right? I'm allowed to do that, that's a 1. What happens when I multiply a square root of 2x plus 1 to that part?
It goes away.
A square root of 2x plus 1 times a square root of 2x plus 1 makes this top part turn into a what? Just 2x plus 1, right?
Mm-hmm.
Now, if I multiply it to the bottom, then it looks like that. But good news, you got common denominators. Right? Did everyone see that? The radical on top just turned into 2x plus 1. Now I got that square root of 2x plus 1. Now there's other ways to approach this. We could have done negative exponents. Like bring that back up and all this, but I think this is one easy way to do it. Oh, I need common denominators. Square root of 2x plus 1, square root of 2x plus 1, I get this. Now we're 2 steps away. I got enough room right here. That's still there. The 2x plus 1 is still there. Everyone, would you distribute this?
Mm-hmm.
What do you get? 6x plus what?
3.
All right. So, what is, do this algebra in your head with the combining of like terms. What's 6x plus 3 minus 3x? I'll say it again. 6x plus 3 minus 3x.
3x plus 3.
No one can see that. Look. 6x plus 3 minus 3x. So you go, there's the answer. But it's still a complex fraction. We just want, 1. Nice. Simple fraction. But so far so good. Was that okay with all that?
Mm-hmm.
That's usually the annoying part of calculus. Simplifying a complex fraction. Oh, that's a radical. All right, we'll apply that. We took care of it. One more thing, though. I want to wrap this up. How you divide fractions, this is over what number?
1.
So you have a 3x plus 3 over the square root of 2x plus 1. I'm then going to multiply by this reciprocal.
Mm-hmm.
When you divide fractions, you multiply the reciprocal. Aha! So look how I'm going to write my final answer.
2x plus 1 plus 1.
I've got this to a 1 power. This is to a half power. And do you remember in algebra you add the exponents?
Mm-hmm.
Good. What is a 1
Plus half.
plus a half?
3 halves.
3 halves. So for the craziest problem on that sheet, that's how I'm going to leave that answer. Unless you want to factor out the 1 on top. 3. So I'll put an or, look. Or factor out 3. In chapter 4, we'll be finding things called critical points. And a critical point would be a point like when x plus 1 equals 0, so that's why it's important to factor like that. But you would have found that x equal -1 there anyways. 3x plus 2 would equal 0. Does that make sense? You sure? Good. That's why I want to give you that. Remember you asked about some extra practice stuff? I got more too. But this one sheet was just focused on chain rule. This was number 22 though, right? Right, everyone? 1 through 13 you probably fly through. We get to the end, we're like, what about there's a radical and you got something with the radical and a fraction. We gotta use quotient rule, but it's not that bad. Is that okay with it? Cool. All right. Now I'm gonna think of some other thing. Here, chain rule. Something I didn't put on this sheet. Something that's not in the textbook. Something we didn't do last class. But nothing crazy. Just when would I need chain rule? There you go. Is this hard? No, but you just gotta be very careful, think it slow kind of thing.
So there are like three functions.
It's almost like it's not just f of g, it's like f of g of h, huh? Yep. Because it's not just cosine of b to the x, it's cosine of e to the negative x. And maybe everyone, before we even start that problem, can I just go off to the side? If this was your function, by chain rule, what would this derivative be?
The negative
It'd
one.
be e to the negative x, right? Times the chain, the g prime. And in these e's, you probably noticed, we always make this part up here and the exponent the g, right? What's the derivative of negative x?
Negative one.
Negative 1. So this would be all this, multiply negative 1 the chain. What's a good way to write that? Negative e to the negative x. And that's why this sheet, let me see how many e's I had on here, right? The natural base, right? The